I did a presentation called Lessons Learned in Supply Chains. And we had just started working with LeTourneau, which is the case study for today. And so what I have is a continuation of those lessons and this case study. At the end of your memory stick is the 2005 Barcelona presentation. I summarized it here. We're going to go really fast because 45 minutes isn't very long. And if you did see Dan Eckerman speak in Las Vegas, this is basically my view of what we did rather than his view of what we did. Most of the slides that you're going to see here were presented at our conference about 6 weeks ago by the LeTourneau team. And so those were the people who actually did the work. So, whoops. So I'm just going to go through really quickly on these because I want you to get a feel for what these people do. This is something they build from scrap metal, okay? This is where they build the components, the electronics, the gears, the hydraulics, all of the structural steel. There's the steel mill that they pull all of that out. They make 6 and 12-inch plate. So this is a custom niche steel mill. Has to be incredibly strong. Has to withstand things like Katrina. And if anybody remembers Katrina, they lost 6 rigs in the Katrina. They're old rigs. They last 30 years. So they were in a real dilemma to get new rigs up. And those rigs had to have completely different engineering specs because Katrina changed the way they looked at engineering for rigs. Okay. These are their loaders. They make the largest wheel loaders in the world, and they're all hydrostatic drive, and they are all electric motors. There's a motor in every single one of those little wheels. They turn on a dime, and they can lift up that pickup that you see beside there. This is the Houston where they make land rigs. Rowan owns them. They do drilling in water and drilling in land. Okay. They make all their own products. The top drives, the drawworks, and the mud pumps. Those may not look impressive, but they're very, very big, and they can drill down 6 miles. So a lot of pumping has to go down. Those things are very, very tough. That's probably the best way to say it. This is where they build those large rigs. So the components all appear in Vicksburg, Mississippi. They build on the shores of Mississippi, and this is a rig being walked into the water. They actually jack up a leg, then jack up another leg, and they walk these things in. It takes about 3 weeks to walk a rig. And when you realize how much steel that is actually a floating hotel, that's quite a feat. Pretty fun to watch. So that's what it looks like once it's in the water. This is their facility in Oregon. They also do log stackers and wheel changers and column cranes. So very big stuff. This is their facility in China. There is good reasons to go to China. Very few people go for good reasons. When they got so overbooked and they found out they were selling a lot to the Far East and the Middle East, they opened up an assembly plant only in China. Okay, so everything else you're still seeing comes from there. They drop these kits in and they build them there and ship them in because they were selling quite a bit to China and India and some other places. So they operate on 6 continents. LeTourneau owns dealers in all of those places, and then they partner with other dealers. So all of these rigs and these vehicles last 30 years. So you can imagine that component supply for parts is an incredibly important part of the business in very large margins. The oil industry comes in 10 and 20-year cycles. You have to live through those cycles. Mining comes in cycles too, and the way that they live is they live off the gross margin of those wonderful parts. So we have a very integrated supply chain. Yes? We started with them in 2004, and I want you to see this chart. 4 years, 5 times X growth in revenue, 6X in race. Pretty nice, huh? Look at 2009. Right now they're doing better than that projection in 2009, but they got hit very hard with the global recession. Nobody's buying big equipment, and oil's in the toilet. So, but look how much better they're doing than they've ever done before. Right. When we started with them, they had a very complex supply chain. Each one of these, this is that steel mill. This is 1.5 million square feet of manufacturing space. All the things get made. They either go up to drive systems and get sold. Drive systems makes those engines, those motors. They're electric motors. And they ship them to the outside, and they also ship them to mining products and offshore products. Okay? So this is really in this environment. These two things are in the same place. Actually, steel, components, services, and drive systems are all in Longview, Texas. But this has an outside market, sells to the outside. This sells to everybody and to the outside because it makes those parts and supplies the dealers. Okay? Steel also sells to the outside, so when you see a little C that says, I'm going to an outside customer. So when you have an integrated supply chain that also sells to the outside, you have some very interesting accounting measurement issues because we have some things that don't necessarily make sense for people. The other thing you have is a very complex bill of materials. We have never run into, we did Ditch Witch in 1997, and they had a 10-layer bill. These people have a 13-layer BOM. Now, and that is after we broke it up a bit. But that is a very deep, complex BOM. Look at the numbers of things we're talking about dealing with. Okay? The very first thing we did in 2004 in October or September is we did a 2-week thinking process program with all the executives of all of those areas. And we basically said, we need a model statement. And we start with something now that we call the to-be model. Because when you're looking at something this complex, rather than going through all of the crud about all the things that are wrong, why not start out with what it is I really want to be? So this statement was really pretty simple. We did simple signal, synchronized signal. It was the S words, okay? That goes across all market segments that allows us to increase velocity and flow, all right? So that sounded pretty nice, but where do you start when you're going to eat an elephant? And that's really what this is about. Because whether I'm starting with a company that is as integrated or vertically integrated and as complex as this, or a much simpler environment, I'm going to start really at the same spot. And what I want to talk about is how we decided where and why you start, where you start with any company. So quickly, in 2005, this is a really quick synopsis of what we learned. One of the things we learned is there's always a market cycle coming, and you can trigger it by some of the things you do to your market, and or you get caught up in it. Has anybody been caught up in the last year? 2 years? Okay. So one of the things we wanted to be certain we did is that we were going to look at this long term with LeTourneau. We wanted to be able to offer them a project that wherever the constraint moved, we would just move there. Usually we do projects by bid. We say, here's your project, we bid the project, and we work the project. So if we're wrong, we eat the difference. And that way it's not a constraint between consultants who like time and money. You understand what I'm saying? So we broke that concept a long time ago. With these guys, it was pretty clear that what we wanted them to do is buy a block of time. Buy a year of our people in our dev group, and we will go and do whatever needs to be done first. And if something shifts, we don't know where the constraint will move or what will happen, and we want to move with it. So they bought into that idea. We had learned that. We learned that by not doing that on somebody else. Okay? The second one, actually on several people. Until you've operated and managed your TOC system through an internal constraint, an external constraint due to an industry downturn, or an external constraint due to a recession, you do not know how to manage your system. And the reason is when it shifts, you must shift all those measures and policies. The system, if it is a good system, will tell you where to go and what to do. But if you've put them in as policies rigidly, your people won't know how to think their way and use the system. They'll be relying on the policy you made, that measure that you made. Do you see what I'm saying? So the system itself has to be capable of sending the right signals in a feedback loop that tell you what to do and where to go. We don't do anything with measures that are, I'm going to say, concrete. Okay? In fact, we don't like those kinds of measures. It's all about the feedback loop in the system. If you don't prepare yourself for the idea that this thing is going to shift and have at least in your mind that if I see this shift here, I will go there, then you set yourself up for really nasty risk. Because people will say to you, well, you know, we were supposed to have this TOC system in. Well, TOC systems are about continuous process improvement. They are not a DBR, a replenishment, a CCPM. That is not what this is. Theory of constraints is about knowing what to do to increase your flow and your velocity in any market situation with the investment that you have, and if the investment that you have isn't cutting it, then what is the strategy to get the investment that you need? Okay? We have to have agreement on the strategic objective of the company assets. The minute you start working with vertically integrated supply chains, you'll find out that you have issues. I'll give you an example. We worked with a really large forestry company, and they had forests, and they had mills, okay? Plywood mills, truss mills, sawmills. If you ask the people who ran the manufacturing facilities, do you have the forest to supply the plants? They'd say yes. If you ask the people who had forestry, do you have the plants to use up the logs you can't sell? They'd say yes. Do you see the problem? Each one is looking to maximize their return on how they view where their market is. And if you don't get that agreement on what the strategic objective is of the assets of the company, then you don't know how to measure them. Because you didn't invest in that forest to sell your logs to Weyerhaeuser. You invested in that forest to be able to make your other investments make you money. Does that make sense, everybody? Same reason with LeTourneau. Why do I have a steel mill? You have to define the supply chain. You have to identify the truly scarce resource or the most variable resource. In logging, it was the tree, okay? And it turned out, in LeTourneau, it was steel. Okay? Nobody knew that, and they were actually trying to sell that steel mill, believe it or not. Agree on the criteria for allocation decisions. Who's responsible for the allocation of the scarce resource? It cannot be anybody who has a vested interest in a market. Let me say that to you again. Who determines who gets the scarce resource cannot be anyone who has a vested interest in any single market. Okay? So it has to be above the market line. Agree on criteria. Let's see, I've already did that. Experience shows that getting control of the input source, is the very first place. And that's really where we start. So when we started with forests, we learned you absolutely go after the logs. You understand how the logs are used, how they're sorted, how they ought to be done, what happens to them. You never want them to rot. You want them to stay in the forest as long as possible. And you don't want that asset getting out to bottom feeders. Bottom feeders are the people who buy things from you, who didn't go to all that trouble to invest in the forest, and then lay it up into plywood and compete against you. Okay? So one of the things that we did with that company is we dried up extra veneer in the marketplace, and guess what happened to the price of plywood in 2001? We were responsible for that in the Northwest because they, in fact, everything west of the Mississippi. You dry up the veneer, the bottom feeders die, and guess what? Price of plywood, your plywood does what? It goes up. Okay? Now, very first thing is wherever you start, do the first thing quick. Because if you do it quick, you get enough results to sustain you through the tough part. Because TOC is about continuously process improvement. Ellie was talking a little bit about that today. You have to get a win up front to get you to be able to have the staying power for an organization. One of the problems people have is they think they're done. You are not done. Okay? The other thing we learned, I guess it would have been in 1999, we started playing with project management. Now, we really stick to manufacturing. We are not interested in engineering firms, but almost all of our large companies have an engineering component, R&D. So one of the things is that we got very good at what we call ASR. You would call it replenishment. But our ASR is really for manufacturing, and manufacturing and distribution have some different quirks. And we learned that quite a long time ago. We didn't know we learned it because we didn't do distribution. But we went back and started looking at all of our clients and how did project management fit into them. And the reason is once you got everything else under control, your constraint usually shifted to the market. In order to be able to deal with the market, you had to be able to deal with your R&D and your engineering. Okay? So those are the issues that we went back and integrated. And we've really found out where and how project management fits into a manufacturing environment. I addressed too. Then the other thing we did is we learned about the control points. If I'm looking at a vertically integrated supply chain, or even just a good-sized company, I'm going to have a control point in the front end. I'm going to say, if I have a sales cycle that's longer than somebody just doesn't call up and order from me, I have some sort of sales cycle, I have some sort of control point in the sales cycle. If I have R&D or engineering, I have some control point in R&D and engineering. If I have a front-end process that makes things and a back-end process that assembles, I have a control point in each one of those. And there's some control point in my marketplace. I want to know what those control points are, even if they are not the bottleneck. Why? Because I want those control points to be able to manage and monitor the front end or that portion of the business, and I want to take that control point and align it to the true control point or bottleneck for the organization. Okay? And I usually don't let those things move, no matter what the bottleneck does. Okay? So if the bottleneck has less capacity than my control point, I simply will take my control point down to the capacity of that bottleneck because it's a better place for me to manage my business from. All right? So we became really clear on what are the rules we're going to have for causing subordination across the organization. Once I know those control points, I can really actually start to design a measurement system. John said I'm sort of the queen of throughput accounting. I really am not. I don't even believe in throughput accounting. Throughput accounting is this much of accounting and finance, okay? This much of a TOC system. The rest is all the feedback mechanism that you're going to use to manage your environment, okay? Measures are not about rewarding, they are about a feedback loop that tells you, are you on track or off? If you're off track, then make a decision about how to get back on track. And then the other thing that we've got down here is something that we call portfolio management. That is different than portfolio management and CCPM. And the reason it is I take all those control points and I look at the types of projects all of them want to have or need to be involved in. Portfolio management for us is making certain that those control points are turned to making the strategic return for the company that it is dictated as a whole. Let me give you an example. When when Rowan lost 6 rigs in Katrina, and within 2 months after that, oil spiked like crazy. Suddenly, we were in the biggest oil boom that had happened in 20 years, right? That means that every single asset for LeTourneau focused from where they were, which was mining products at that time, because mining products was booming, they were both booming, but the return on investment for OP, offshore products, was huge. Everything went from here to there, immediately. Now, that doesn't mean that I don't try to satisfy all my markets, but if I'm going to get a return that's 2 and 3 times any other market I have, and besides that will sustain me for the next 20 years because of the aftermarket parts, it's a pretty good bet that that's where I need to go. Does that make sense to everybody? So that's what we call portfolio management. All of the projects that are in the entire supply chain are put into project management investment portfolio, and then we decide what those control points will work on, or someone does, and they make sure they stay aligned. All right? If you take a look at the implementation timeline, we really started right here. This is DBR with technology. We did the steel mill first. Why? Because the steel mill is the beginning of the cycle. If I take a look at if I just take a company, or I take a vertically integrated supply chain, I'm going to try and get my hands on the sources of variation at the input and at the output. And at the output, it's the market signal back to the input. At the input, it's the beginning raw material. With forests, it's logs. With LeTourneau, it's steel. Okay? Does that make sense to everybody? So it was very clear to us that the place we needed to get our hands on first was the steel mill. They had about 60% on-time delivery, tremendous complaints. They said they couldn't make any money. And these guys, well, tremendous job. The next place we moved to was that 1.5 million square feet of incredibly diverse manufacturing called component services. And we basically put in a manual DBR system. And the reason why we didn't use our technology is because our technology could not handle that scope of business. And in fact, there isn't any that can. They were using throughput. It can't handle it either. And in fact, your MRP system won't handle it. It just doesn't work. 13-layer bills is incredibly difficult. If you're interested in how and why, go see ASR. Carol and Chad have a really good presentation. They'll explain to you what are the flaws and how it works and why it doesn't work. But that was the next place we went. Manual DBR with ASR. That's our version of replenishment. It's actively synchronized replenishment. Basically what we did is we decoupled points in the manufacturing process by looking down the bill of materials and deciding where to decouple. Get a control point in each one of those decoupled areas and put in replenished parts in between, okay? And that's the easy version of it. Huge gains by doing this. And then right about here, we had the tsunami hit with Katrina, and everything switched to OP. And offshore products, CCPM, we'll talk about that in a minute, but it was really clear that this was the bang for the buck. And you'll see the results on that. Then we moved to DBR with technology for offshore products. So everything that was in Mississippi, they have their own manufacturing, their own assembly. They have their own design engineering and their own drafting. Okay? After that, we moved to DBR with technology in component services. So we basically sold them our dev group time, and we developed the technology that would be able to handle an environment like LeTourneau. And that is, we put that in spring of 2008. We grabbed, well, we'll show you what we did. We grabbed a portion of that CCS, of that entire 1.5 million square feet, and said, you are the drum. and we put in DBR with technology just there, and we let everything feed off of it. Signals up front, signals back on both sides. Then this is going live with DBR for the whole 1.5 million, actually in 2 weeks. Okay? Right now, there's a push to do lean. They're doing lean in Houston, and DBR with technology will end up with, in Houston, we'll start that process in August. So you look at this, and this is the process this is how you eat the elephant. Let's talk about the to-be model. When we basically started with them, every single person who had a C outside ran their own business group. So they all competed for the scarce resource. And when they didn't like what they got, they went outside to Mexico or somewhere else. And then when they brought the parts and they didn't work, so they sent them to CS and they reworked them. Okay? Tremendous mess. Okay? We ended up with putting, anytime you see this little thing, it is a strategic replenishment buffer. This is a time buffer for DBR or CCPM. Okay? And if you see this is a remote location. They have distribution all over the world. And of course, that is an end customer use. So you can get an idea of how we put the buffer systems together and then how we decided to focus. All right? Supply chain drum. From day one, we said to everybody, it is absolutely clear to us that component services is your supply chain control point. Okay? We learned later where it would be, but this puppy feeds everybody, yes? Okay? And the steel mill feeds them and feeds OP and feeds outside. All right? Strategic asset and major source of variation, so get your hands on it first. Okay? Every time you take out a major source of variation, what happens to your flow and your time? Okay, let's talk about that. We had a buffer, we put in a buffer of steel plate between the steel mill and CS and OP Mississippi, okay, OP Vicksburg. If you ever want to spend a wonderful summer, spend it in Mississippi. Okay? 2 summers. These are the Forest Products Mining Group, Drive Systems, OP, and CS are all sending demands to the steel. Most of these are coming through CS, but they also come directly to steel. Okay? So here's my steel mill, and what determines the size of my buffer is the order frequency cycle and the maximum time to reliably replenish. When we started with them, it was 12 to 14 weeks. Now look what happens. If you shrink the time to replenish, then you can shrink your buffer. So when this thing got to 6 weeks in January 05, remember we started in November 1, 04, huge impact. Right now it's running at about 4.5 weeks. Okay? So tremendous flexibility and a lot less inventory in the environment. Yes? Do that right up front. Okay? Now, if you looked at this lead time from here to here, it would take you 22 weeks if you tried to put an order in for the steel you needed. Okay? What we really wanted was an 8-week cycle time for any end product. One of those big mining things, I want you to order it and I want you to get your custom bucket, custom loader, they're all custom, out in 8 weeks. How can I do that? How can I do that? I can do that by putting replenishment here for all items that take longer than 8 weeks. Okay? And if something doesn't take longer than 8 weeks, I don't need it in replenishment. Right? OP, same thing. Now, this is our CCPM implementation. If you think that this looks simple, I'm going to show you how not simple this is. This is steel and CS supplying replenished parts. These are time buffers between engineering because I have to have the drawing done before I can make the part, right? Okay? And I have to have the drawing done up here in design engineering, but then it actually has to go to Mississippi and become all of the parts that are done down here, and it ends up in the yard. This is called a slab, where those parts come together. All of this is not design engineering, it's manufacturing engineering. So you have all of those parts manufactured, engineered on site. So they have about 50 manufacturing engineers in Mississippi. All right? Now, this used to be a 2-year planning and execution horizon for a new in-class rig. Okay? Now, the project for CCPM, this is a high-level network. Let me show you what that really was. 83 projects, 12,000 nodes, and 600 P2P connections. If you know anything about CCPM, anybody who's seen this said, I've never seen. Concerto said, gosh, we hope it will run. And it did. It's a very good product, Concerto. It's my plug for Sanjeev today. But it's an amazing product. And you could not do this without technology. In fact, you could not do this supply chain without technology, all three technologies. Okay? So the thing that we put in place, and we learned to do this, this is a synopsis or a summary of how we view you have to have your system stable for anything. Even with 1,500 people, you need an environment that does this. This is your measurement loop. But this is what we did with LeTourneau. We made something called strategic, let's see, what's SPL? Strategic Planning and Logistics. They changed their name halfway through. It used to be Central Planning and Control, and they didn't like that. It was CPC, which was easy for me. SPL is Strategic Planning and Logistics. Basically, what we have is a global dashboard. There are four technology products that are used: Concerto, R+, DBR+, and XA is the system of record. These things all go into SPL. This dashboard is your feedback loop, okay? And I'll show you those measures in a minute. Then basically what we have is SPL's job is to have strategic oversight over the capacity management, the process improvement, sourcing, buffer management, inventory analysis, and portfolio management. That's SPL's job. They have no connection to any market group except that they want the executive team to tell them who and what gets priority first. Does that make sense to everybody? And this basically took out the fight. What you've got here is a wonderful little cycle of how do we decide where our next process improvement comes from? Where's our next project going to come from? It comes out of these dashboards and the audit findings. We've been doing audits for 6 years for our clients, and we developed a process that takes about 3 days. And when we have the technology in place, we can use the output from the technology, because what you're looking for is day-to-day execution and then a feedback loop that gives you the ability to know what's what over the last 3 months. What are trends? You know, what are things doing? And where to apply that. So those audit findings basically then make a business case recommendation to the executive team. If the market segment head says yes, and they don't have to pay for this, it's not allocated across to them because no market segment wants to be having an improvement process charged to them. If the executive team says, oh, you're it today, you get to be it, okay? Then they have a sponsor from that area. You make a priority, a scope, PRTs, thinking process is used dramatically through this whole thing. Then you go into execution, blah, blah, it's done. Now you see. 5-question format is the other thing we do. If you have questions about that, I'll answer them, but they're in 45 minutes. I mean, that took months to put together. I don't have time. So, at a global dashboard level, this is what we use. We use what we call the 5 questions, and they are: what's the condition of the buffer, whether it's CCPM, DBR, or replenishment? Are the trends getting better or worse? If worse, what's the buffer recovery plan? Is the buffer recovery plan effective? That's part of your feedback loop. And then what change do we have to make to ensure that the problem doesn't reoccur? All right? Now, thinking process tools are used in this, but these are the questions that everybody from the floor to the top are trained to ask. If I'm on the floor, I do this in execution. Okay? If I'm at a management level, I do it weekly with my management staff and the planning and control people. If I'm at an executive level, I do it biweekly and monthly and quarterly and annually. All right? And that's how this feeds into that SPL feedback loop that you saw. We use it to focus our audit approach. Now, let's talk about the next step. We put that little feedback loop you saw in at the beginning of 2007. And what we did with component supply in 2007 is mining products was part of this CS. It was a separate, it had its separate assembly. And in 2007, even though we'd said business groups should not have anybody reporting to them that's in manufacturing, they had left mining products assembly reporting to the head of mining products. And what they did is they undid that in this time frame, and they moved everything into CS. So mining products had absolutely no assembly left except in China. And now there was only one thing happening in China, and that was a pretty good move. So what we did is our audit showed us we had another conflict. Okay? So we got rid of that level of conflict by moving the business group out of a reporting structure that was causing the conflict. Okay? In 2008, it was really clear with CS, we had done 4 debottlenecking. In simple DBR or manual DBR, you really can't use good buffer management or the process I'm talking about. So what we had done is we looked for where the bottleneck is, we debottlenecked. It started out in machining, it moved to cutting, it moved to fabrication, and then it moved to this wonderful place called Drive Systems. And Drive Systems was a standalone electric motor and all of the electric components that go into those loaders. And these things are very sophisticated. I mean, if you were to look into the cockpits of those the drilling rigs or the those large machines, it looks like, I mean, you might as well be driving an airplane, okay? It's not that bad, but it's pretty amazing. This was a standalone building because it had to be a clean building, the only building that's clean in Texas. In Longview, Texas. In LeTourneau, Longview, Texas. Didn't mean that the way it sounded. And it was a perfect place to say, you know what, we could take and put technology there because every single product, whether it's wood products, OP, or mining products, has to have one of those. And they were so far behind, they were actually causing us, they were going to cause them to miss shipments. In fact, you'll see a little decline in OTD in the beginning of 2008, and it's really because of this. So we took it and we put in the technology, and we let the MRP system and throughput go ahead and release orders at the front end, but we did not release anything into Drive Systems except inside how we run our DBR system. So we basically took and put a mini DBR technology system in the middle of this 1.5 million square feet. And I got really excited when I saw that it had moved here because it was the first time I could actually get my hands on a control point that we could really use good buffer management. So what we saw here is this, they call this 880-184. And if you look at this, it's pulling all the way through here, and all this variation was showing up. And these guys weren't getting them their parts, and then they weren't getting their parts to assembly. Okay? So that's what happens when you have lots of variation. So what we did is, we wanted those buffers. That had been our original plan, but we didn't have any of those buffers because we're on a manual DBR system. So reality was, we attempted to manage that entire 1.5 million square feet. Pretty tough. So instead, we decoupled 880-184. We put a staging buffer in here, put drum buffers in here, and then these guys fed on time to the assembly due dates. So their due date to on time was when assembly needed it. And they became the drum for all of LTI. These guys basically looked at those buffers and said, I have to get your stuff on time. And that means we caught up 16,000 hours of work in 10 weeks. Pretty cool, huh? And these are the graphs that come out of our technology product. So, visibility, it's key. Visibility and velocity. If you get those two things, you get flow. So this time was the first time we didn't debottleneck. And it also gave LeTourneau the notion to say, okay, we will buy your dev time. We want that product to go the whole 1.5 million square feet. So that will come up in 2 weeks. Okay? Powerful thing about LTI, they met all of their market commitments in 2008, 2006, 2007, and 2008 without any major capital improvement. And in fact, next to nothing. And they did it with this process. And if you look at that trend, let's go back and stop. I mean, we're talking a growth of 6x in revenue. I'm sorry, 5x in revenue, 6x in race. Those are better that way, aren't they? Yeah. Okay. So, all I'm talking about is you need some, if you're going to do replenishment, these are the benefits of replenishment. We do not put in any DBR system without replenishment. In fact, replenishment always goes in first. And the reason is your system is too noisy. If you get the replenishment out and break it, you can get the noise out enough that you can find the right drum, and you don't have to worry about the buffers being so big, because your buffers have to be big enough to deal with what? The true variation of your environment. So we always put in replenishment first, and we go to the end points of the system and put in the DBR systems. Now, one of the things that you saw, the benefits that these guys got, remember that 1.5 million square feet? We're doing manual DBR. We put in replenishment right away. Got huge jump, up to about 85% OTD, okay? Down from, maybe 60. That's pretty amazing. And it was really pretty simple to do, okay? In an upturn, it did amazing things for them. But guess what just happened to everybody last November? We're in a downturn. So what did I tell you? If you have a system, you are not learning how to run it until you run it in 3 different environments, right? So is this thing going to work for them? These are the things that they got in an upturn. These are the, if you put in replenishment and you want to be able to do it well, I believe that these are at a minimum some things you need. Okay? So your replenishment system needs to be able to do those things. But, and this is the quality fill rates they got from that, but what I really am talking about is how does it help you in a downturn? Because ASR is critical, replenishment's critical in an upturn, but it's even more critical in a downturn. Because they went from thinking they would sell probably 50 loaders, 50 large machines, those are $2 to $6 million machines, to thinking they would sell 5. Okay, that is, I mean, and that happened overnight. That happened to everybody, didn't it? Okay. Now, we'd kind of known this was coming, or people kind of thought it might be coming, but we didn't think it would be as bad. Nobody really knew how bad it was going to be. So in a downturn, this is what it does for you, which is even more critical than in an upturn, because when you're growing, you can cover a lot of sins, can't you? And inventory's tolerable. But in a downturn, if you want to survive, in fact, is Wally in the room? Okay. Tube Forgings is speaking today. Ask them about why they're doing okay. Ask versus their competitors. But they're still making money. And they have 16 times less inventory for the same parts as their competitors, and their fill rates are at 100%. It's replenishment. Okay? Critical thing here is one of the reasons that they were able to meet their revenue targets without adding capital is they did go ahead and outsource some parts, and we did it smart. Okay? Pretty desperate, but smart. The critical thing about outsourcing is how do you insource when times get tough. So one of the things that you're looking for is be certain that you have really good criteria for why and how you insource. You better really understand your drum when you decide to insource. Okay? Outsourcing, understanding your drum is critical. Insourcing, it's even more critical. So we had this lovely little cloud. What had happened is Mining Products couldn't get all the things they wanted because they weren't at the top of the food chain. Offshore Products was. So they did open this assembly plant in China, and it was the right thing to do, and they only took 2 loaders there. But you know what happens? The minute you get an assembly plant, you start ending up with a little shop down the street, and then another little shop down the street right next to that assembly plant that nobody knows about. So suddenly, when times are scarce, Mining Products now has this little assembly thing going in China. So the engineering people, you know what they get to do? They get to say, I want you to... I can specify who the supplier is. So guess what they started doing? Specifying non-LTI supplier. Okay, so this became a cloud that we had to work at the executive group because the head of Mining Products didn't want to let this thing go. Okay, so thinking process is still alive and well. The whole point for this up here is that if you're going to insource, be certain that you look for everything. Feed your children first. Okay? Okay, there is your decision points on how to insource. Answer those questions, you got it. The other thing we did is we took and made an extract out of ASR that basically says what I'm looking for is I'm looking for total days in the routing and days due to outsourcing. Now, if I have total days in the routing that are 36, and I have 25 days that are due to outsourcing, what I was looking for is the products I want to bring in first are the products with the longest outsource time, because what can I do to my replenishment buffers? These are only for replenished parts. Shrink them dramatically. So when you're looking, there's a good criteria about how to do that, right? Look for the ones that cause you the largest, what we call an R+ lead time, okay? And make certain you bring those back in first. So there's a criteria about how you should bring things in and what you should bring in first. The next thing you ask is, what's the load going to be on the drum when I do this, okay? But if I have a lot of capacity, I want to be looking at getting a double bang. That lead time reduction gives me my inventory reduction. So I'm going after parts. If I have parts that I'm not replenishing, that means I'm not replenishing them because they're already inside the lead time I need to keep my market. So I'm not worried about those. The ones I want to get that I'll get, and I don't get any inventory reduction for that. I don't get any cash. So that's what I'm looking for. Okay. When you do anything, you better be looking about the potential negative branches. There are suppliers they want to keep for their future. There are strategic suppliers. So one of the things that you do is, it's not that you don't bring their parts in, if it said to. I rearrange parts that they were making somewhere else to the people that are few that I want to keep. Make sense to everybody? So what I'm saying to you is, every time you use a strategy, be certain you use the thinking process tools. You cannot do theory of constraints without good thinking process tools. So what you're seeing here is part of that SPL audit process, which says, I get the information from my technology, but I use the thinking process first to deconflict my executives, set up the right policies for the new process, because my constraints shifted from internal to external. I did that right. That's amazing. From internal to, I've been saying internal constraint for so long. Yeah. So how successful were they? I want you to see this. I love this chart. This is their on-time delivery. That's that little blurb when 881, 884 wasn't keeping up. This is their revenue growth. This is their inventory growth. Is that pretty? Now, Ellie said today, these things are all connected. Damn right. So you get velocity, you get flow, you do the right things. Inventory doesn't grow, race does. Okay. This is a chart we use to say, are these guys doing the right thing? When you turn off when you take and slash your budget, your forecast for the next year, and you have long lead time parts on order, it doesn't just go away overnight, right? But what this chart shows you is that already, by using good ASR, good replenishment tactics, you see it coming down ahead of lead time. That the orders being ordered are canceled in the right order ahead of lead time reduction. Okay? So that's really what this chart shows. Now, remember we had that little OP, CCPM, this is offshore products? When we did OP, what we did is we said we wanted to be able to make 2 rigs in the time it took to make 1. They got that. That's amazing. It takes, I don't know, 2 million man-hours of welding time in a rig. That means it takes 2 million man-hours of welding time to make 2 rigs versus 1. Pretty amazing, huh? So we wanted to go to 3 rigs in the time it took to make 1. And guess what happened? That got canceled. So what did they do with CCPM? Did it fail? Is it still a failure? No. They wanted to move that thing out. And we said to them, don't do that. Because then all that overhead will stay that much longer. Keep it pulled in tight, and instead go into the yard and take out 400 people. They had 400 temporary employees that they'd had for ever since about Katrina. Okay, so they took out all 400 temporary employees. If you do the math on that, it's about $65 million. And what this shows you is the tasks being completed from the time that they took these out has stayed the same. So the rate of compression absorbed that labor reduction. Okay? So that's a $65 million OE decrease. The rigs will come in on the same time they were going to. They were going to move them out and let those 400 people go. And we said, no, let the 400 people go and do not move them out. Go for the compression and let's see how tight we can make this. And they've kept it up. So not anything to sneeze at. It also means that this rig will go into production in 10 months sooner than it would have. Even today, they'll be able to rent that rig. Not for the $100,000 a day they could get in the heyday, but they can get $50,000 a day. 10 months of $50,000 a day, pretty good. Okay? Make sense to everybody? And all I'm showing you is TOC works in a downturn, it works in an upturn.